Well, one of the most exciting things in tech almost always has to do with scale, right? Is it big? Is it fast? Is it going to change stuff overnight? And generative AI is kind of exhibit A these days. When OpenAI released ChatGPT-3, I think it was in October or November, million users in 5 days, right? And growing ever since then, which kind of got the world's attention. If you've been coming to these meetings, generative AI was probably not a surprise. The uptake may have been a surprise. But for the world, it was a watershed. It was a huge surprise. And perhaps not the best understood surprise either, because people think it's a mind. People think it can be turned into a Nazi. People think the robots are taking over our lives. Well, that not yet, but things almost as dramatic are on the offing if our panel is to be well heard. They maintain this, and I am inclined to agree, but the specifics of how we get there are to be determined. We are moving with generative AI from an AI that is predictive and somewhat efficiency-oriented to an AI that is creating novelty in the world. And that is a profound statement having to do, as we go down the panel, you'll see, with the nature of various industries, the nature of scientific discovery, the nature of the creation of data sets, which is at the heart of creating this AI. So perhaps it enables itself and grows even more than we expect, which is a pretty exciting scale concept in itself. It's creating novelty in the world in text, in video, in programming code, in molecular models. It might be hard to figure out where it's not going to touch. People say it will be in almost any consumer product. That's a big part of the world. It's a huge change. It's a huge change for the world. It's also a huge change in the hardware demanded, in the software demanded, in the skills demanded, in the calls on data sets, all of this background stuff, where fortunes are made and where things are changed and where we spend our capital investment, our educational investment dollars, all have to speak to this to really have it reach its full extent, which raises a number of questions about the areas that are affected, the ROI, the speed with which this can be done, how this works into the existing all-important world economy. So we have about 45 minutes to answer to all that. I don't see a problem here. How about you? But let me have the panelists introduce themselves, because I think that's more efficient to begin with. Why don't you each state your name, say your company, what your company does, and then say what aspect of generative AI you're involved in and why you chose that. And I'll have a follow-up related to that. Okay, Amir, why don't you start?
Thank you. So it's wonderful to be here. My name is Amir Hussain, and I'm founder and CEO of Spark Cognition, which is an industrial AI company based in Austin, Texas. For the last 9 years, we've been building platforms and products that help customers in energy, renewables, aviation, defense, and also manufacturing. In many of these applications, we've applied our technology to problems like predictive maintenance, being able to find a problem before it occurs, prescriptive maintenance, where you can actually augment the workflow of a human user as he or she maintains an asset. And then cross-asset optimization, where you're running a wind farm and you want it to be extremely optimal. You might want to turn down one particular windmill and have another one come up so that the overall farm, the load is distributed and does well. So we've applied artificial intelligence through our products to many of these areas. We've recently added visual capabilities as well over the last year. So now we have what we consider as the first industrial generative multimodal platform. Multimodal referring to video, acoustics, text, all sorts of data coming into the same platform and being able to reason over it. Now, the big successes that we've seen in generative AI, which we've been working on now for the last couple of years, this week, in fact, I can give you a preview. This week, there'll be an announcement coming out from Spark Cognition, formally launching our generative AI platform. But the idea here is that many of our customers, many of our large industrial customers have told us over time that, look, we don't quite have enough data. We don't have data of the right quality. We don't have the people to collect the data and put them in the right places. And in these circumstances, generative AI can actually come in, take small numbers of samples, create distributions, then create synthetic data that allows effective bootstrapping and effective training. That's, I think, a revolutionary step forward for industrial adoption of AI. Beyond this, of course, ideation has no limits. We can apply these types of techniques not just to improve the resolution of images or to find reservoirs of energy, but also to augment the way in which systems are designed in the future. We work with the DoD. That's another area of application for this technology. So generative AI unlocks AI applications from the need for tremendous amounts of data. It can step in and fill in gaps where that data doesn't exist or has never been captured. And finally, it can create these streams of ideation that can feed on each other in a multimodal way, bringing in many types of data, data types like images and videos and so on, and create something very, very compelling in the end, the likes of which so far we haven't really seen in the community. It's not just going to be text in and text out, but it's going to be text in and video and images and sound all out, and then conversing with that, creating novel simulations. It's going to be a very, very different world over the next few years as this technology takes off. So that's a quick little background on what we do and how we have come to using generative AI in industrial applications.
Gavor.
Yes, it's wonderful to be on this panel. I'm Gavor Grigorian, co-founder and CTO of Generate Biomedicines. And Generate is a machine learning-based protein therapeutics company. The foundational principle for starting Generate was really that we can use data to understand the generalizable rules, generalizable principles by which all proteins work, and then use those principles to generate novel protein molecules that are completely new. They haven't existed in nature, but they play by the same rules as natural proteins, so we have a high likelihood that they actually work correctly. And then use that capability in service of creating novel medicines, so proteins that have desired functional and biophysical properties encoded into them. And so that allows our platform to be applicable across disease areas and across modalities. And in terms of why we chose to use generative AI, I mean, it was very much the foundational idea behind the company in the first place, but it also felt like it's a really timely idea in terms of helping the drug discovery industry really become more efficient and be able to discover medicines much faster and be able to respond to emerging threats as they occur, rather than being married to very long timelines that are inherent or have been inherent in our industry to date, that also increase costs of producing medicine and ultimately lead to drugs that are too expensive for many people to have access to them.
I have to jump in right now and take moderator's privilege. When you're deciding what sectors, disease and disease treatment is nearly infinite. Do you base your choices on best data set, largest market need, number of players? How do you have to make choices about where you'll apply this drug discovery?
Exactly. And it's actually even more complicated than that because our platform is general, we don't actually need a data set in a specific disease area to be able to tackle it. So even that in some ways doesn't help the choice dilemma. So that is actually one of the most complex problems that we're dealing with at Generate. And there are multiple ways in which we kind of prioritize opportunities along a number of different axes. But one thing is we view, and I think that's one of the maybe topics that we'll get to later, but we view partnering as a very important way to alleviate this tension. We know we can do some of the work ourselves, but by virtue of being generative AI driven, our platform is going to propose many more ideas and solutions than we can ever act upon ourselves.
Right.
So doing it with partners is an important part.
Not just as students, but as company owners, you want to see your work expressed in the world as best possible. Now, Sriram, you're with IBM. I think we've heard of it, but what's it doing in generative AI?
Yes, I won't try to introduce a 110-year-old technology company, but
we might be here a while.
But I'm Vice President at IBM Research. I'm responsible for our global AI research strategy, and I work with the commercial parts of IBM. So if I step back a little bit, I want to maybe disentangle generative AI and sort of introduce two other related terms, because overall, I think it's important that they are related, but I think some of the benefits accrue. So this notion of self-supervised models trained on unlabeled data broadly, foundation models is a term sometimes people use, I think it cuts across a lot of the benefits that even my co-panelists have talked about. So that's one phrase. When you apply that kind of technology to natural language or things that look like language, then we call them large language model. And these capabilities let you do both classical AI and the new forms of generative AI. And I think this bigger context is useful because when I look at what we're seeing in the market, from an IBM business perspective, our focus is on what does it take to take all of these innovations and make it real in enterprises? And our strategy is really around hybrid cloud and AI. So what does that mean when we look at large language models, foundation models, generative AI? What does it mean to bring it to the enterprises? We see two things. From an application perspective, if I had to pick one word that describes the opportunity space, that word would be automation. Automation at the enterprise across every workflow. And the reason I say that is huge is you can look at automating the work of an SRE, that's IT operations. You can automate, help the work of a security analyst, application and cybersecurity. Use of AI and generative techniques to automate or assist customer service agents. So every persona in an enterprise has the opportunity to have AI assistants get to the next level with these technologies. And why this inflection point is interesting for us, I think goes back to something we heard, which is the biggest challenges enterprises have had is the scaling of AI has been hard. It's not been hard to find one use case or two use cases. It's been about finding how do I scale AI? And I think these technologies have the opportunity to take down the cost of operationalizing AI, take down the skills level needed by doing a lot of upfront work in these large models. So we are very excited about that possibility. And we are looking at uses of generative AI technology in 4 areas where we have existing market presence and products: cybersecurity, IT operations, digital labor, or business automation, and customer care. The other side of our strategy is we firmly believe that this technology is not just going to be the domain of the AI technology providers. You're going to be building generative AI models on customer data, on enterprise data that enterprises have. Which means, the second part of what we do is what is the platform that lets enterprises who live in a hybrid estate with public clouds, multiple public clouds, private clouds, what is the platform that lets them do generative AI wherever their existing enterprise estates resides? So that's the second piece of our strategy. So bring enterprise automation and then enable platforms that allow companies to build these kinds of models on their own data, customize, fine-tune, adapt these models. Those are the 2 big vectors of what we're doing.
So tame it, as it were, automate it, as it were, and promulgate it as broadly as possible.
Correct, with one additional color that I'm sure we will get to, which is how do I bring control, trust, and governance?
Right.
That becomes very, very essential, and that's another piece that I'm sure we'll get to as we go through.
It's counterintuitive, but before I mention it, I should also mention I do not speak today on behalf of Google, nor could I explain anything they actually build. So it is counterintuitive to say it's going to drive the cost down because right now this form of AI is associated with extremely high cost, high capital undertakings.
Yes.
Do you think that'll change?
Two answers to that. I think one element of that equation is the amortization. If you can upfront invest to build a large model, then the payoffs as you scale them to derivative tasks over time will bring down the cost. I think the second thing is also goes back to, we've always run into the issue of, in traditional approaches requiring large amounts of labeled data to be able to do a task. Suddenly, I think the number of possible enterprise use cases also scales up. So it's not cost in absolute terms, it's cost relative to the value you can extract out of it. I think the cost equation will change, which will accelerate enterprise AI adoption.
See, this was all by way of teeing up Aiden, who no longer speaks for Google either, but used to in very important ways and has broken out to create a company called?
Cohere. So hey everyone, I'm Aiden. I'm the co-founder and CEO of Cohere. We're a company that builds large language models that compete with GPT-3, ChatGPT. Before starting Cohere, I was at Google, part of the brain team that created the transformer, which is the T in GPT and BERT. And we watched it get deployed all over Alphabet's product areas. We initially built it for Translate. It was then adopted into search and every other part of the entire company. And it was driving huge change and massive value for that organization. But there was for my co-founders and I, there was a dissonance where we didn't see the outside world changing. We're consumers too, and we use the same apps and websites that everyone uses. But as a researcher interacting with this technology, it was something magical. It felt like we were glimpsing the future. It was the first time we could talk to something that isn't biological, and it talks back in an intelligent way. It felt like we were seeing something that I thought would come a quarter century from now or half a century from now. And so at some point that dissonance grew so great that we realized we needed to be the ones to bring this to the world, to transform the surface area of technology and give computers the ability to understand and use language. And so that's what Cohere does. We have like a very simple API. Pretty much any developer can use it. You don't need to be a PhD with a decade of experience working in AI. And for us, our focus is very squarely on enterprise. It's great if you can come up with a cute consumer application where you can write a poem about a dog or a parakeet or something, and that's fantastic, but there's still a lot of barriers on the path to true transformation of the enterprise and the products that we all use and love. So I'm super excited to be here because we're building this category of model on the language side, which people are very, very excited about. But I still think that there are barriers, and one of the core barriers is data privacy and protection. And so enterprises, I'm sure many of your organizations, the general counsels are shutting down access to ChatGPT because it's taking in information that's sensitive and then regurgitating it to other users. And so for Cohere, data privacy through partners like AWS, GCP, Oracle, Azure is core to us. And our whole mission is just getting this technology in users' hands into enterprises as quickly as possible.
I have to ask, when you had access to it at Alphabet and it could talk back to you, did you ask it if you should quit your job?
I didn't. I don't know.
You really should have.
Might have been pre-programmed.
I don't know, it could have been a really bad outcome. We're going to stay positive here. But it's interesting. And earlier when I was speaking with Amir, we were talking about this. One of the intriguing things about enterprise use cases and industrial use cases is it seems like it would be better risk management. The data is understood, the rules cases are understood, there's less incentive to misbehavior if it's kept close. So
100%. Like I think with Bing Chat and Sydney and everyone's like barred that whole event. I think everyone has seen the limitations of the technology. And I think that's because that stage of tech was released a few months too early. And it was the product of a race dynamic. And so the technology will get there. What you saw were examples of it not being truthful, it fabricating information, it hallucinating information. That's actually a really complicated behavior. Like the model doesn't want to imagine information. If it has access to a reliable knowledge base, it's way, way easier for the model to just copy and paste from a reliable source of information than it is to dream up some fabricated story or fact. And so we're on a very clear trajectory towards production readiness for billion user products like Google Search, but we're not there yet. What we are at a stage where we can start to handle is exactly what you point out, where enterprises have much more refined, much more reliable knowledge bases. In Bing Chat and Google, you're accessing the whole web. And so anyone can throw something out on the web. That'll get indexed by Google, and now it's treated as a source of truth by Bing Chat or Bard or whatever, right? So you can see the problem with that. Anyone can maliciously input false information that will just be regurgitated and emphasized. Within enterprise, that's a much more refined knowledge base, and so it's actually a safer, more effective, deployment environment.
Right, and the outcome is more finite as well.
Yeah.
Like, we want to save money. We want to build a little efficiency. Like, not trying to plan a trip to Spain or something complex.
Right.
Yeah. But I think there is a trade-off in the sense that you want the benefits of the fluency and naturalness, but balanced against the grounded truthfulness, right?
Dial that up in an industrial
Yes,
context.
in an interesting way. And I also think there's another element, and we spoke about this. There is an ROI element, I think, that's critical for enterprise discussion, in the sense that, yes, if I can amortize the cost and scale it out, there should be operational benefits I'll be able to more rapidly roll out. But I also think that there is a rich design space emerging, which is, what model sizes and what combination of pre-trained, fine-tuned, adapted models do I need? And what's the cost equation when I look at lifetime value? As an example, if I have a use case which is going to give me yay benefit from a business ROI perspective, now maybe the fastest way to roll it out is to simply fine-tune a massive model and always do inference on the massive model. But suddenly for this yay benefit, I'm paying this yay cost. Now, we know that these costs aren't reflected today in the API numbers because there's a market capture effect going on. But the reality is that there will be this journey around understanding what combination of model sizes and customization, pre-tuning, fine-tuning makes sense. Because when you look at the lifetime cost, it's not just the cost of training, it's the cost of fine-tuning, adapting, and then actually doing inference. And you got to be able to take that whole cost equation into account. Because if I'm trying to save money as an enterprise and automate, I have to make sure that I chose the right path. So I think there's an interesting space emerging of large models, but what's the large for the right use case in an enterprise?
Okay. One of the interesting problems in generative AI, I think more than in traditional AI, is the whole question of prompts, the type of question you ask, and how that influences. I had a really interesting exchange in the differences of answer I got by asking, how do I choose versus how do I decide? It took those two words that seem very close in entirely divergent directions. And that's just a small issue, or a small way of expressing this large issue of choosing and setting up the generative AI to work appropriately. So in the spirit of that, you've all chosen to be in certain parts of this, and let's start with Aiden and work down. What are one or two areas you chose not to be in that you also think are great? And the real goal of this is that one of you will give the other his resume at the end of it.
Right. Well, I actually think two areas. I think that vision and stuff like image generation, video generation is super cool, and in another timeline, I think I would have loved to lean in there. But we were just speaking about it, and I think that like protein design, the design of RNA, DNA, using these large models, large models of the language of life as opposed to the language of...
Now, are you choosing that because it's a great business or because it's mind-blowing and will utterly change life as we know it?
Impactful. It's just impactful. Like the amount of good that you can do by spending your time on that is quite extraordinary.
It's impactful, and it's also interesting in kind of objectively because you're naming an outcome and asking it to back up and give you the process to create the outcome. And that's an idea that can really generate or transplant into a lot of other sectors. So, Amir.
In my view, the couple of areas that we are not pursuing now, which I think are terribly exciting, the thing about generative AI is it's not just about text, it's not just about images. Those are the two consumer applications that people have seen a lot of. It's more than large language models, it's sort of large token models. Anything can be broken down into a token, including atomic captures of human actions. As you lift a hand, as you bring it down, as you let's say, play a shot in tennis. All of these things can be atomicized into individual chunks. Each one of those can be represented by a token. And these same machines that are predicting sentences can predict gameplay, as an example. There's some work happening now in labs that are taking these types of models and connecting them up with robots. That, to me, is particularly exciting because it brings the same type of architecture that can generate imagery, that can generate text, but that can also form essentially the nervous system that implements muscle control. So increasingly, we start to see the same type of genetic structure expanding in its ability to do things. In an industrial context, obviously, being able to control machinery is a huge deal. And it goes far beyond being able to detect a problem or being able to find an opportunity predictively. Now you can do something about it. So that is really interesting to me. It's something that we will pursue, not pursuing at the moment, but there's a ton of applications across both manufacturing, logistics, defense, just across the board.
And
Yes. So
say Aiden gets into the business and clones you. What is the new version of you get
right.
into?
So I mean, we've obviously early on made a decision to focus on medicines and health applications. There are obviously lots of applications of generative AI outside of that. But that meant, for example, for the time being, not focusing on other applications where the ability to design generative proteins can be useful, and these are applications, in material science, and nanotechnology, and defense, just to name a few. We are starting to think about, ways we can enable others to be able to pursue these applications, because again, the foundational platform being centered around proteins and being able to generate proteins that perform bespoke functional tasks is really broad. There are applications in sustainability, for example, or recycling, or degrading plastics, et cetera. So we are, as technologists, we'd like to see our technology being used for those purposes. But in terms of building the company, it's been important to kind of focus our own efforts on medicine and health.
Absolutely. But sustainable energy, industry, defense, that's an enormous.
It's a lot.
Do you see people developing in all these areas? Do you think
Yeah, I mean, one of the nice things, one of the benefits that I have is my background as academic. So I've actually, collaborated on projects that have started applying, abilities to design proteins in these areas. And so I think, yeah, absolutely, there's a ton of work happening in these spaces. Yeah.
Okay, so sure, I can't really say what are a couple things IBM isn't choosing to do, but
maybe I'll state it differently. I think the right is we're in the business of enabling other people to do it. So that was from a platform perspective.
Right.
So there are some that I told you that we're in, that's in business and ID automation and security where we have businesses. But we're in the business of enabling people, whether they want to do language, whether they want to do medicine, whether they want to do industry, enable them to build and exploit. But let me throw one other particular example of a partnership that we have, just because that domain didn't come up from my panelists. We have a partnership with NASA. We're working with them to build foundation models in generative AI, in geospatial. So potential to transform Earth sciences completely. That's a domain where, again, NASA by the end of the decade will be sitting on 600 petabytes of Earth science data. What is the opportunity to apply generative AI to flood modeling, sustainability, crop protection, emergency response? Huge. So I think that, as a platform provider, we have that luxury of not picking, so answering your questions both ways. Picking our swim lanes, as well as enabling others to pick their swim lanes, and I can cater to both. So we, for example, also work with companies in the materials domain, enabling them to build generative models for new materials for carbon sequestration, new materials for better nitrogen fixation, new materials for better drugs. So I truly believe that what we're seeing is an inflection point in the AI workflow. So eventually you will see this applied everywhere AI is applied. I think we're all picking swim lanes based on current market opportunity and business sense. But as a platform provider, we are fairly agnostic.
All right. Now that we've transformed the world economy and life itself and the nature of science, I think it's time for the hold on there, folks part of our program. What are some of the big stumbling blocks ahead? This thing isn't baked yet. what are some of the parts that still need to be built? The big tough problems inside this before it becomes widespread?
Yeah. Well, in my view, there is a few things. First of all, I think this work on kind of multimodal networks needs to happen and needs to be accelerated. The ability for these models to understand enough about knowledge representation across different types of data so that they can convert between them and they can use a picture to augment a piece of text and so on, this is going to be important. The other thing is the age-old problem with many of these deep networks, which is explainability. You came to a conclusion, and now you have very convincingly given me some finely written prose to make your point. But why did you think this? There's a little bit that you get in these LLMs, but it seems to be post facto justification of the type human beings do. It's not really first principles justification. And one of the reasons is because none of these models have an internal world model integrated into them. The idea of an emulator or a simulator within which they can test their hypotheses, determine some kind of an outcome, and then use that as a filter to create an output, that yet doesn't exist. So I think adding that kind of simulation capability and internal testing capability is important. These are, there's a ton of other stuff, but I would say these are three core areas. Now, my own desire is to see this idea of intrinsic motivation, where when we started looking at reinforcement learning, one of the core concepts there was, well, most of these algorithms are, here's a bunch of data, give me an answer. The model takes an input, model gives an output. ChatGPT, same thing. Give it a piece of text, gives you a piece of output. But what internal voices are going on? What other processes inside that society of mind are going on that make it a thought system as opposed to a query system? So this move from transformers and LLMs and large token models from being a one-shot query mechanism to a society of mind, and I use Marvin Minsky's terminology around this, individual LLMs and token models all interacting together, playing different roles with intrinsic motivation, a self-propelled problem solver. That to me is very interesting, and it's something that clearly I would like to contribute to making happen.
To boil it down, you'd like the machine to be able to explain itself better.
And also reason on its own and not rely on human beings for every interim piece of input as it provides an answer.
I think when it comes to applications of ML to medicines, I actually think it's probably less, the biggest limitations are probably less around the techniques of machine learning itself and the kinds of architectures or even things like explainability. We can certainly talk about limitations there, and these are areas of active research. I actually think the biggest limitation is around data and availability of the right kinds of data sets. And so this is why at Generate, as much as we've spent time innovating on the machine learning front itself, we've also made large investments and large strides on the level of data generation and being able to generate at scale, biologically relevant, accurate data. And as I sort of look at it broadly as a field, I think that's where we should innovate as fast as possible to see ML and generative AI play as big of a positive role as possible.
Shriram.
I would second, obviously, the discussion around trustworthy AI. I would also add an element of risk assessment. So we've seen this pop up even with traditional AI, and I think the large models in generative AI don't make it easier. They actually make it harder. In the sense of, you talked about explainability. It's only gotten harder. If I have a big model that I didn't build or I didn't control as my starting point, it was hard enough to do explainability when I owned the entire AI workflow. Now today, if I'm seeding a portion of the AI workflow to a large model, it gets harder. But I think the answer to that is not therefore to stymie the adoption of the technology. There's obviously science going on actively, but is also to understand what kind of risk assessment methodologies and auditing capabilities that you can bring to bear so that you can put the right guardrails before deploying them. I'll take the simple example. I think there were references to synthetic data generation as a big and important capability. So one of the things that we have seen a lot of appetite for as one example of what more we need to do is a platform that lets you understand and evaluate synthetic data generation across a number of dimensions. If you're doing synthetic data generation using these large models to mitigate lack of data for your original use case, obviously you want it to be useful, have high fidelity relative to the original data, preserve privacy, does not introduce a bias. There's trade-offs. How do I understand the trade-off? How do I make it easy to control the synthetic data generation? So I believe that the next set of things we have to do is, one, improve the core capabilities of explainability and so on, but also improve the process between the capability and a deployable capability. There are steps along the way. Risk mitigation and assessment are those kinds of things. And I think as they make progress, they will scale up enterprise adoption. You don't always have to solve the problem at a model level. You can solve it down the road as well.
Okay. Aidan, I'd like you to answer it in terms of both the system you see at large and what you're hearing from customers. Like, where are they having the biggest problems?
Okay, I was going to say something different.
Go ahead. Say something different.
On consumers. For me, like the big concern with large language models, and maybe more generally generative AI, is synthetic media and our inability to distinguish human created or authentic media from synthetic media. So you can imagine scenarios where phishing can be scaled up astronomically. You don't need humans writing these phishing emails anymore. Right. It can be fully automated. You have scenarios where social media, you can't trust whether the message that you're reading was written by a human and it's pushing some particular idea or objective into the public consciousness. Or breaks in our legal system where you can't trust the image or the video that you just watched and you have no ability to authenticate. I do think there are resolutions to a lot of those. I think that you can have some form of, human verification, and there's a stamp of approval on social media saying that account is verified as a human, and you'll pay a lot more credence to posts from folks that are verified like that. Similarly, we can insist that images taken by cameras or recorded by video cameras, that they're in some way tagged by that camera manufacturer and authenticatable. But in general, that's work that needs to be done to update our systems like social media and like the hardware that we use to capture media, so that we can have those protections in place. For Cohere, on the enterprise side, a lot of the barriers are around data and restrictions on that side. Folks don't want to send their data over the wire. And so the ability to go where the data is, whether it's on-prem or whatever cloud provider you're on, close that gap, that's something that needs to be built, and Cohere is very focused on that.
Nobody mentioned cost. Nobody mentioned cost of computing. And isn't this a very expensive thing to do still?
It is. I mean, though, in medicines, frankly, it pales in comparison to the cost it takes to develop a drug these days. So I think, that's not to say you couldn't scale compute to a point where, it becomes bigger. As I think we would all agree you certainly can. But I think what we're seeing is that we can build incredibly useful models that completely change how we can think about even what type of molecules we can think about bringing into existence versus before, at a cost that's still very much a fraction of what one would spend to develop even a singular molecule, let alone an entire industry worth of molecules.
If I can add to the cost, I think two observations. One is, I think we are sometimes misled in the cost discussion only by looking at the largest models out there serving consumer needs. There's lots of value you can create by domain-specific models, still get a lot of the benefits. And yes, they are expensive, but I don't think they're always necessarily expensive at the scale that we see. I also think over time, we will see the cost focus shift away from training more and more into fine-tuning and inference. Because eventually, in these domains, you're going to do that way more than you're going to train. And I think that is when really, I think, the cost equation. So to some extent, the reason maybe you're not seeing cost is as these deployments start to scale, I think we will start to see cost and ROI come back, but it will start to bite on the inference side.
Well, one of the challenges also with cost is just the fact that it's not just about training the model, which can be $5 to $20 million, for these large models. There's a whole bunch of machinery on top of these models. The word prediction mechanism, which is the bulk of that training effort, is only part of it. ChatGPT, as an example, is not just that model. There's a whole layer of reinforcement learning on top of it, which is also not available to most people. So the question is, the cost of building a service that looks a certain way versus just a model. And I agree with my fellow panelists that I think if you narrow down the focus in on a domain, reduce the amount of data, you can still do a lot of valuable stuff. If you try and compete with, say, GPT-4 or WuDao 2.0, yeah, that's going to be double-digit, triple-digit millions of dollars.
Mm-hmm.
Yeah, I think like the unspoken assumption here is that you're going to have to do it yourself, and you're going to have to train one of these models yourself, and that's just not true. Like part of the thesis of Cohere is that you need resource sharing, right? And so one company foots the cost, and maybe, yeah, we're paying 100, 150 million a year to maintain that, but the companies using us are paying 2% of that. Mm-hmm. And so resource sharing is a key part here. Don't reinvent the wheel. There's not enough supercompute on the face of the planet to support every organization building their own $250 million supercomputer to train their GPT-3. It makes no sense. And so resource share and use services that are specifically equipped to build and maintain those models, and you build off of them. There's not enough value in that part of the stack. All the value for these enterprises looking to adopt this tech is one layer above that.
Right, and you can see that, you can see that on a kind of macro and micro level, where if the demand on these large compute jobs increases, people build specialized accelerators, and then they build specialized accelerators against even more specialized jobs because the demand goes up. I mean, that's been going on for decades in this industry, and will probably follow, particularly where writing software against it is concerned. There's plenty of work to be done here. I wanted to pick up on something Aidan said earlier, touching on understanding, which touches on ultimately regulation. If we are changing the entire world economy, life as we know it in science, it's likely the governments are going to get involved. Yeah. And that can be healthy as long as there is healthy understanding. How well do you think the general public understands what's going on in this field?
Yeah, I mean, I think ChatGPT was like a watershed moment. Like some light bulb flipped on. 6 months ago, if we were having this conversation, I probably would have started, hey, here's what a transformer is, here's what an LLM is, here are some example applications, and folks would be trying to wrap their heads around that. Now, everyone has first-party experience interacting with this thing. They've spoken to it, they've talked to it, they've used it, and so you can actually enter into that conversation with them bringing the ideas. Yo, I just used ChatGPT to do this, it's crazy, can we apply it here, can we do this? And so there's just been some sort of flip in awareness, and everyone sees the potential. Everyone has first-party experience actually talking to this thing.
To maybe amplify on that point, I think, the public, I would humbly submit, and I would include myself in that category, doesn't really understand most technology, right? I certainly don't understand in detail how my laptop or my car work, but I'm still able to make good decisions about using these pieces of technology. So I don't think we necessarily need to look to explain in detail how machine learning and generative AI work, but there does need to be a stable API, sort of stable input-output relationship between the public and these models, just like we have with cars. I don't know how it works, but I know I push the start button and I drive. And frankly, we're still working that out, right? I mean, I think even kind of we on the stage, I'm sure, would differ a little bit on that subject. And as the scientists and the technologists are figuring it out, I think it's important for us to kind of export that to the public as fast as possible, so that we can have good regulation, good understanding.
I think more than the public, I think I agree that there's been an inflection point, at least in experiencing the technology. But I think to me, more than whether the public understands it or not, to your point, they don't have to really understand it, the experience. There is a potential for misunderstanding, if you will, by the regulation, which can go one of both ways. Because if the entire color on generative AI and its use and potential is colored exclusively by the ChatGPT experience, you are likely to also fall into the wrong way. So I do think that the onus is on technologists to disentangle this a little bit. May not necessarily be to reach the public at large, but definitely to make policy and decision makers. You don't want to limit its use in, let's say, science and healthcare based on artificial regulation as well.
I think there's also a lot of places in the world that are kind of less regulatory focused than the US now has become on topics like AI. And a lot of startups across domains, including AI, are finding the ability to partner with global partners and kind of develop the technology to a point where it becomes a proof of existence at a certain level of quality. And then maybe those things come back. I mean, in autonomous aircraft, that's kind of happened with Australia and the US and with other technologies as well, long range, beyond visual line of sight drones in Africa now coming into the US. So I feel like with artificial intelligence that there's also a possibility of really forward-leaning countries looking at other jurisdictions in the world, going and doing the thing really, really fast there, and then getting it to a level of acceptability and safety, and then bringing it back into markets that are more highly regulated. That is a business strategy.
Okay. I see we're out of time, but I want to get one last question in because we have investors and big companies and startups in the audience. You will all be around for conversations. In your next 6, 12, 18 months, what are some areas where you particularly want to partner, or how would people speak to you about investing, or how would people speak to you about using your services? What would be the most productive kind of a conversation for you?
Well, Spark Cognition is now at a point where, in a couple of years, we'll be breaking even. We've got sufficient amounts of capital. Our focus is on partnering with investors to scale the company faster. We've done a great job integrating some acquisitions. There are some companies that, particularly in this market, are very interesting to us that we'd like to continue to add. Global expansion is another element where we've shown success. That's another area, the use of capital. So yeah, we're not formally raising around at the moment, but these types of strategic uses of capital and even increasingly joint ventures in other parts of the world, we're exploring these 3 areas. And those would be the types of partnerships I would love to discuss.
Strategic growth.
Yeah, so for us, obviously, we're always interested in finding ways to enable others to make fantastic medicines. That's in addition to our internal pipelines. We have an ongoing partnership with Amgen. So similar partnerships are always of interest. Partnering with folks who have specialized data, either on patient data or medicines manufacturing data. And we are going into, we just started our Series C fundraising activities. Our CEO, Mike Nally, is here at this conference. Yeah, so definitely would be very happy to talk to any interested investors.
Sure.
2 elements. One is obviously, and we have some startups already working with us, if you're interested in taking your technology, bringing it to the enterprise, we have both the platform and the access to really make that happen. So partnerships where you are innovating at the higher layers and you can take our platform and use that to deliver that technology, those kinds of partnerships. The other one is industry domain specific. We talked about it. There are some swim lanes we are in doing it ourselves. There are many swim lanes in which we are happy to be enablers. So partnerships where we work together to build industry and domain specific models would be very interesting.
Okay, Aidan, last answer.
Yeah, I think for me, conversations around changing your product or changing your business with LLMs, and in particular the next generation. The ones that we have today, they're still rudimentary. The most they can do is stream some text back at you. And so folks who are really thinking about the next phase, which is LLMs that can take action, that can do work for you, they can integrate into APIs, etc. So conversations around, changing your product and business using those models.
Outstanding. Well, I'm sure I share the audience's feeling. We wish you well. Let's give him a hand.